Hello, everyone, and thanks for joining us today. On behalf of the Environmental Finance Center Network, welcome to the webinar today on QGIS for Water Utility Management. My name is Tess Clark with the Syracuse University EFC, and before we get started, I just have a few housekeeping items to cover. So first, some logistics. Everyone is going to be on mute just to ensure audio quality. Please use the question box to submit any questions that you may have. You can do this at any time during the session. We really look forward to hearing your questions and comments, so please feel free to send them in. Additionally, we will be posting a recording of this webinar on our website. The website is www.efcnetwork.org after the webinar. It typically takes us a few days to get that processed and posted, but you can also find the link to the recording in our follow-up email, which you will receive in the next 2 to 4 business days. All right, next, we can't guarantee that this webinar will be accepted for any kind of professional development or continuing education credit. We don't get our webinars pre-approved by any state or licensing agency. However, we can provide a certificate of attendance. In order to receive a certificate, you need to register with a valid email and you need to follow the instructions in your GoToWebinar confirmation. We can't verify that you're participating if you're watching it on a friend's computer or without registering. We will email your certificate of attendance to you within 30 days of the date. And if you have any questions, you can just email us at smallsystems@syr.edu. All right, now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small public water systems in all U.S. states and territories to help local systems achieve their managerial and financial goals. Our technical assistance is free for systems serving 10,000 customers or fewer. So if you hear something that would meet your needs today on this webinar, keep us in mind because we might be able to help you. And here's just a quick snapshot of the various centers that make up the Environmental Finance Center Network. We work together to create solutions to difficult how-to-pay issues of environmental protection and improvement. And on that note, our speaker today is Eric Porse. Eric is joining us from the Sacramento State Office of Water Programs, where he is a research engineer, and Sac State is also the Region 9, the house of the Region 9 Environmental Finance Center. So thanks, Eric, and before I hand things over to you, I'm going to start off with some quick poll questions. So I'm launching our first poll, which is, have you previously heard of QGIS? And I'm seeing a couple responses in, so I'm gonna wait a few more seconds before I close the poll. I'm gonna close the poll in 3, 2, and 1. And it looks like we have 56% of folks today don't know what QGIS is. What do you think of that, Eric?
I think we have the right audience.
Great, okay. And then we have one more for everyone just to get started. For the folks that said yes, do you currently use GIS in work related to your water system? So go ahead and tell us, take a few seconds, think about whether you use GIS often, whether you use it sometimes, or whether you never use it. I'm going to go ahead and give you 3 more seconds to respond. So I'm closing the poll in 3, 2, and 1. All right, so 47% said sometimes, which was the majority of folks that had heard of GIS or that are using GIS. 32% said never, and 21% said often. I don't know if you have any if that encourages any insights from you, Eric, but I'm going to go ahead and also make you the presenter at this time.
Thanks, Tess. I appreciate it. Hi, everyone. Greetings from Sacramento State. My name is Eric Porse, as Tess mentioned, and here at Office of Water Programs, we've been around for 50 years. We support water and wastewater utility training, continuing education materials. That's how we got started back in the 70s. And since 2016, we've been the Environmental Finance Center, and we're happy to be part of the network along with our fellow centers across the country. So thanks very much for joining today. I hope everyone is staying happy and healthy. So today we're going to talk about QGIS for water utility management. And in the poll questions, we saw how there's decent number of utilities around the country or attendees that are using some sort of GIS already. And there's a number of different platforms potentially to use. So we'll talk about what QGIS sort of means for opportunities to use GIS within water utility applications. And then also, just kind of to mention at the outset, our goal today is really to kind of have something for everyone. So for the poll attendees who say they already use GIS, maybe this will be an introduction to QGIS and some of these tools, or perhaps it'll be an opportunity to sort of compare and think about what your future needs are. For those who don't use GIS currently or don't know what GIS stands for or anything of that nature, then we are going to try to have some basic information to get you started as well. So a little bit of something for everyone is the goal, and then we can follow up with discussions, and we're always happy to help within the ESC or connect you to local ESCs in your neck of the woods. So with that, let's get started. So Geographic Information Systems, or GIS, they're an increasingly popular software platform for use for all sorts of applications across society. They're very valuable for utility management for a number of applications. But their basic definition, you can think of GIS as software systems for storing and analyzing data that has spatial information. And they allow you to do analysis, they allow you to view and create maps, overlay maps to customize them, and provide a wealth of potential analytical opportunities, anything from calculating area to identifying locations within, associated with other locations. So there are lots of different types of geographic information systems, and Esri's ArcGIS is the most popular. It's been around the longest and has the most commercial support in the industry, but there have been a number of innovations over the past 5 to 10 years, QGIS being one of them, but other providers as well, that have better tried to integrate applications on your desktop, which would be software you'd use with just local files and local computers, and integrating that with potential web mapping applications, which are quite useful and in order to help with dynamic decision making or presentations and so forth. But the whole idea of GIS is that you're really bringing maps to life and that you're able to use them more than just sort of having a flat piece of paper. So QGIS is a free and open source version of GIS software, and it's been created over many years by a community of developers, and it's under continual improvement. So there are new versions of QGIS released generally every few months, and you can download beta versions as well as sort of established versions. The most recent versions are typically going through some sort of beta testing, because this is a software platform that is within the open source sphere, which means that the community of developers is continually creating new opportunities, new innovations, and also troubleshooting. And so what that means is when you identify something that might not work, it's not the same as having a commercial platform. You can't go and call a helpline when you're using an open source platform necessarily. What you end up looking for, where you look for answers, is the online community, and so you'll see posting boards with questions and answers, and you can go to posting boards and sort of see folks reporting bugs and having developers fix bugs and so forth. So it's a line of software development that really draws on the expertise of folks who are either volunteering time or sort of creating a nonprofit institution of some sort to be able to support better access to software tools. And over the years, QGIS has really become a lot more robust and stable in its offerings. Now, how does QGIS compare to some of the software platforms that you might have used in the past or that they're commonly available? Here we have a table that sort of compares 3 different platforms, QGIS being one of them, as well as the Esri's ArcGIS, the standard commercial product, as well as Google Earth. And Google Earth isn't technically a geographic information system. It's software for mapping within your desktop and integrating in a number of different features. But it doesn't sort of store and keep information in the same kind of way that a GIS does. So technically, you can use it still for a lot of spatial applications, but technically it might not be considered a GIS. All 3 of these applications are good for mapping. For spatial analysis, though, you start to see the value of GIS, and this is really where utility management benefits here for the sorts of applications that utilities need. And so Google Earth has some very limited spatial analysis capabilities. You can evaluate area. We've used it to evaluate impervious surface cover in case study areas, for instance. You can evaluate lengths, and these can be quite useful and as a lightweight tool for doing that. So it can be quite helpful for smaller water utilities, for instance. And then with Esri's, ArcGIS, and QGIS, they have a number of integrated or add-on plugins that you can use for spatial analysis. Anything from intersecting, one type of entity in a location with another type of entity nearby, calculating distances, all sorts of potential functions. For the cost, of course, this can be a big issue, and so Google Earth, free and paid versions, depending upon sort of the versions that you want. But then within Esri's ArcGIS, that's a subscription-based service. You might have a subscription to it through your municipality, so you can always look at, use those opportunities. And then QGIS is free. For file and database support, the file support for Google Earth is limited. You're oftentimes having to convert files between different formats. And then Esri's, ArcGIS, and QGIS, they both support a broad array of file management and file types. Esri has a proprietary file type called a geodatabase, which can be a very useful feature for pulling together a lot of different information. So a geodatabase might be, one type of file that a GIS analyst would work with in ArcGIS that wouldn't necessarily be easily convertible to QGIS directly. But if you went into the geodatabase and pulled out the individual information, you'd be able to map everything in QGIS and upload it. And then the database support can be important for advanced functions, maintaining a record of assets, for instance, and both GIS software platforms have some support for that. Online mapping, if you're looking at advanced opportunities, you really get your GIS program up and running in your utility and you want to help provide it for decision making or allow for public access to web maps. All three of these kind of platforms can support some type of linkages, but it will require some software development, and you might have to engage either your expert team in your municipality or a consultant in that regard. And then finally, what might be the most interesting here is, who has integrated water utility analysis packages, not typical in Google Earth. ArcGIS, Esri has been supporting this for a number of years, building up libraries to help particular industries, and the water utility industry for stormwater, wastewater, water supply, utility management. The number of applications is growing, and we know a number of utilities that are using these packages. And then in QGIS, there's not necessarily a direct utility set of packages for you to be able to use. You kind of have to know what you need to do, and then you can do most of the functions that you would need. But it wouldn't be sort of plug and play, as we'll show. But there are a few add-ons that can help you with particular tasks that you would need to do when running, say, a watershed management or a water utility program. So in summary, QGIS supports analysis and mapping similar to ArcGIS, but it doesn't currently have the integrated solutions for utility enterprise management and advanced utility operations that is supported through the commercial offerings of ArcGIS. So if you open up QGIS, which we'll do a little bit later, this would be sort of a basic screen that you would see. Similar to any kind of software program, you have a few different windows that you can use. So your file browser on the left, it lets you navigate and create some easy links. I tend not to use the file browser very much. Your layer box down below that shows all the different layers you're mapping onto into the map window. The map window in the center, it's where you're exploring. It's dynamic. You zoom in and out, similar to a lot of mapping programs you'd be familiar with. Right here, we're looking at the San Francisco Bay Area, and this is mapping parkland areas from a California statewide database. Over on the right, you have a toolbox, which we'll take a look at a little bit later, but the toolbox is quite helpful. It's a feature that's been built up over a number of years, and it integrates in functions, analysis functions that have been created specifically within the QGIS program, but it also integrates in several other open source GIS platforms. And as a little bit of information, the open source community for GIS software has been functioning for many, many years, and some of the original tools, namely a software program called GRASS, was more a command line option, so it didn't have the visualization window. But it had some pretty detailed capabilities for doing spatial analysis. So as QGIS has gotten more robust, they've integrated in GRASS as well as some others more directly so that you'd be able to use those tools. And then on the top, your menu items across under the layer menu, we'll take a look at a little bit later, are adding files, and sort of the layer is how you're able to bring files in for mapping and analysis. So some GIS basics, some file types, just in case for those who might not be familiar with them. So vector files are essentially points, lines, polygons, and you can have databases with attributes and information associated with it. You can sort of think about vector files being organized as a table, but then with additional attributes to be able to map it on a GIS within a GIS framework. So vector files for utilities, they might include assets or agency boundaries, parcel boundaries, streams, watersheds, these sorts of features. Raster files, on the other hand, are essentially pictures. So they are detailed pictures where the pixels have some information associated with them. And raster files often tend to be quite a bit larger than vector files, depending upon how detailed the pixels are. So if you think about your typical camera, if you take a higher resolution picture, it takes up more memory, and raster files are the same way. There's a number of different types of information that are stored through raster files, commonly stored, that you might end up encountering or wanting to use. One would be a digital elevation model, where the raster file contains a single point of information at a particular location for the height, mean above sea level, or to some reference location. A lot of climate data is stored as raster files, so precipitation over time or temperature, and then land cover as well. And on the right, you'll see an example of the National Land Cover data set, which has 20-kilometer resolution, I believe, information for land cover. Not necessarily what you'd need for, say, stormwater applications and mappings, but detailed and quite useful, and it separates out trees and pervious surface cover and so forth. And then finally, table files. So this is data with spatial information. Tables are a component of vector files, but you can also just upload a CSV file with point information, say for some features, and we'll see an example of that a little bit later. Some additional basic GIS concepts. So a coordinate reference system is a CRS. And so a CRS is define how to project a 3D map onto a flat representation of the Earth. If there is an issue that you're using in QGIS of you can't get your map to show somewhere and you can't figure out why it's mapping somewhere, the CRS is sort of the first thing you'll take a look at, right? So they're kind of a fundamental concept that if you're just getting started with GIS analysis, you'll want to do some reading about. There are hundreds of different coordinate reference systems, and they project maps in different ways. And so some typical CRS, you might be used to seeing, say, your state and counties look a particular way. And if you use a different coordinate reference system, it may not project in that same way. So within your area, you'll probably have some common some common coordinate reference systems that you'll end up kind of using in a standardized fashion, and you'll want to sort of convert over all of your files to those types of CRSs as you're building your GIS library. So GIS software needs to interpret the CRS, that input from a file in order to map it. So if it doesn't do this correctly, it won't map it correctly. And like I mentioned, that's one of the major issues you'll see when you're just trying to get started with GIS, is making all of those things match up. Unfortunately, when you go out to grab data from GIS databases and repositories on the web, the coordinate reference system, which would be stored in data with that file, is not always apparent. And so sometimes it can cause trouble depending upon your location of the data and how the parties that have made that data available have published it. So some additional QGIS, some views of windows you'll see. So you can see that on the left-hand side, map and some of the boxes a little bit more simplified. It's customizable depending upon what you'd like to see. So here you're looking at LA County and mapping the storm drain system in LA County. And then on the right-hand side is a layer properties box, and you can see all the different types of fields with data for each of those attributes. So in a sense, for this particular map, each one of those little orange lines, which represents a pipe within the system, has a set of attributes associated with it. So you can potentially see here how this is valuable for storing utility data in a way that you can use it for both analysis and record keeping via Excel or another tool, as well as also mapping it. Here's an example of an attribute table within QGIS, and I'll highlight a couple of terms here. So one record, a row of table in a data, would be just one feature. And so here, looking at that utility, the stormwater utility database that's published by LA County, you can see a number of different fields with different information. So pipe width, pipe size, materials, and so forth. And each of those fields is then standard across all the different attributes, so you have the opportunity to fill in individual records for each of them. This looks a lot like an Excel table, and you can use this to go back and forth between platforms, say within Excel or a spreadsheet program, over to GIS and back and forth. And so it becomes very valuable when you're able to sort of map information that you can either write out in tables or collect in the field, and we'll see an example of that a little bit later. Now moving to a little bit more water utility focused opportunities using QGIS. We at the Environmental Finance Center at Sacramento State have used QGIS specifically for some applications such as utility system mapping, so pipes, gutters, storm drains, for instance, or in the other sectors, water supply pipes, wastewater pipes, so forth. You can use it for asset management. Like I said, there's no plug and play solution for that, but you can evaluate, associating pipes with properties or associating billing data with properties and storing information about properties. You can look at within the system, where items are located, collect information on them, such as height, or topography above sea level, attributes that you fill in, such as material, most of the typical fields you would use through an asset management program. You can also use it for watershed analysis. If you're involved in, say, a regional watershed group, or you're involved in watershed planning for your utility, you can use QGIS to evaluate, for instance, your stream flow network or create watersheds similar to the tools that are available in ArcGIS. And this is really quite a useful application of GIS tools in supporting this watershed delineation. And then we've also used QGIS for rate studies. Applications from what we've looked at is more sort of exploratory questions around affordability, but you could use it for more fundamental work in rate studies to identify average billing and so forth, because you can do many types of calculations within the tables sort of attributes analysis functions within QGIS, but then also have the opportunity to be visualizing it at the same time. And I just want to emphasize that if you're using QGIS, there's not a lot of plug-and-play solutions for water utility management, but the opportunity is that it's free, and it's a great opportunity to get you started. And so if you start to understand how to use GIS in your utility applications, then you can build up a program, and you can likely make a case to your, say, board of directors or others of, here's all the stuff I've done with a free program. Now, even if there's provided support and we institutionalize this, then I could do all these other things as well. And we've seen those sorts of opportunities happen within our networks in the past. Now, add-ons in QGIS are essentially packages that third parties write, and there's hundreds and hundreds of add-ons available. If you want to find an add-on for a particular package, the best way to do it is to go to Google and search QGIS add-on and the thing you're looking for. And a number of different posting boards might pop up where folks have answered questions previously, and you can get a pretty good idea with about a half hour's worth of searching or less if there's a good solution for you. The more recent the information is, usually the better, because the software is always changing. So the community of developers, they'll write packages, and then they'll go through some testing and bug development to error check for bugs. And then it can actually become even part of the regular function. So over the years, add-on packages that you can add separately are actually sometimes integrated into QGIS functions, so they become part of the software that's released through development. So it's really kind of a living, growing piece of software. Some recent packages that I've seen are actually designed to assist with particular water utility management needs and utility management needs more broadly. So a lot of these, some of these are more established and new functions within QGIS, and some of them are actually new packages that have been recently released. So QWater supports integration with EPANet and some drainage planning applications. It's a pretty neat software package for QGIS. Free as well, like I said. Saga is another one of these broader GIS platforms, and it has a lot of excellent capacity for terrain analysis. And so here's what I was mentioning with the watershed delineation and other functions too that are quite helpful. And QField, I actually just found while working on this presentation, we haven't used QField as of yet, but it's a quickly developing, fairly robust solution for field data collection that integrates with QGIS. And this is, we see across the environmental finance centers, this is a continual challenge of having an affordable solution to get field data and surveys into platforms for, such as Excel for analysis or asset management or mapping. It's one of the items we'll be digging into a little bit more, but any field testing and any stories from the community would be very interesting. So we'll take a few slides, a look at an example, and then we'll try out some live software in action here. So looking at an example for asset management, last year we put on a small workshop here for field data and asset management using GIS at the Environmental Finance Center at Sac State. And we sort of described how you sort of organize the data and then use it for mapping. So asset management, you're going to have a record of information for all of your assets within your utility service territory, and they'll have a number of different attributes associated with them. And you can store those all in a table, and might look something like below in terms of having individual records for asset number 1, 2, and 3. And then they'll have all the possible attributes, those fields that we looked at previously in the table, for a number of different characteristics that are helpful, engaging, lifetime, expected lifetime, asset life. These include age, length, depth, size, location, material, condition. And the idea is with an asset management program, of course, you're going out and you're collecting information on, say, condition, to be able to help you assess, replacement needs and upgrade needs, and provide and cost out your utility requirements for the coming years. So it is possible to do field data management using some open source and free solutions right now. You could go out and start this tomorrow, right? But a little bit more, it's certainly more prudent to sort of look at the solutions for long term, how you want to set up your utility to do this for success. The value is if you haven't done this before, then a little bit of field testing can be kind of useful to get you an idea about how things will flow. And when you're collecting field data for asset management, you'll have some platform, either commercial or open source, that you're out in the field gathering information on particular assets. And that can be exported or automatically uploaded to some sort of database. There are commercial providers that allow you to do this quickly, just from the field. It'll update it automatically. ArcGIS, Esri's functions have been building this out significantly with their enterprise utility management opportunities. Or you can simply export it to data files and then just an Excel file, a CSV or an Excel sheet as well. And then it leads to a number of different applications for asset management, for operational planning, capital planning, and you can create the online and desktop maps. And we're going to see a simple example of that in a minute. So during our training workshop last year, we went out and collected some field data with an open source app that was developed through EPA, the Environmental Protection Agency. The software isn't necessarily being continually uploaded, continually updated for now, but there are a number of different potential opportunities you can use just to get your feet wet for the moment. So you can go out and collect field surveys, just write it down in the quote-unquote old days, or you can use a mobile application. And then you can export it here to an Excel sheet with with all of your different attributes that come out of the application. This particular application we used was a mobile app developed for the checkup program for utility planning systems called CUPS. It was developed by the USEPA. That software isn't being directly supported at the moment. There's certainly a lot of interest across the U.S. in asset management. So there's likely to be some more solutions available in the future, but also there's plenty of proprietary solutions that do this much more succinctly as well. Okay, so as I mentioned, let's see an example of using QGIS a little bit here for some applications. So if you open up a QGIS window, this might be what you see. You can customize your view here of the different boxes you'd like to see, or the toolbars you'd like to see as well. But as we took a look, you have the browser window over here. You have layers here. There's no layers currently being mapped in this. You have your processing toolbox over here, and then your menu functions up on the top. So we're going to go ahead and add a layer. I'm going to add a layer of California counties to begin, just so we get some reference points. And so this is the data source manager you'll see. If you're used to using ArcGIS, it's akin to add layers. So again, if you go to layer and add layer, I mentioned in that comparison table, it's a little less succinct to add data in QGIS than it is in ArcGIS, because ArcGIS will sort of take and interpret what type of data it is you have. Here, you have to understand what type of data and tell QGIS how to upload it. So you have to know if it's a vector layer, a raster layer, or a text layer. And vectors, again, are kind of points, polygons, that shape files, if you're knowledgeable on that terminology. And then rasters are those pictures. So we'll add a vector layer to begin of California counties. So I have this vector layer already available here. So I've uploaded the file that I know that I want to use, and I'll hit add, and I'll hit close, and we have our counties in California. When I was sort of mentioning coordinate reference systems, you can change your coordinate reference system in a number of different ways, either for the layer itself or the whole coordinate reference system of the full mapping window is down here. I'll show you quickly what happens if something doesn't look right. If I try to map it with a separate coordinate reference system, this doesn't look like the California I would recognize. So if your maps look odd, don't fret. Sometimes it's just a matter of a little playing around with it to get the view you want and looking at some posting boards. So you can change the coloration scheme on this quite easily. Over here, now you see a layer has appeared within this box, and I'm going to double click on the color box associated with the layer, and it brings up a text box for symbology. So there's a lot of different opportunities you can do here. You can make it look all sorts of crazy colors, psychedelic, whatever you'd like. But we're going to simply remove the fill. And so I'm removing the fill color here, and a lot of these you can interpret fairly easily if you spend some time with it. So I don't want any fill for my counties, and I've now removed the fill. So I just have the borders. So anything that'll show up on top or underneath is not being covered over by those layers. So a nice feature that has been built up over the years within QGIS is similar to ArcGIS. You have a number of different potential base maps you can add. And this is the latest version where there's there's lots of different base maps from a number of different providers. So we'll add one of Esri's standard base map layers, and you can see underneath now we recognize where we are in the western part of the U.S. with Nevada and California. So I'll zoom in on our fair county in Sacramento, and you can see here now I've zoomed in far enough. I'm seeing the outline here. It looks a little dark, so I'm going to go back to my shading and fill this in and improve that. So the coloration schemes, I'm walking through just a few of those items because they really help you to bring the maps to life, as I was talking about, and they help you to be able to use and communicate the information you're seeing with GIS. So now I'm going to zoom into the Sacramento State campus here. And you can see our campus grounds, uniquely placed to maximize our flood risk between the American River and the flood control system protecting our city. So we are sort of located, Sacramento State, along the American River right here. And we have, because of that, we have an interest in protecting water quality. So a number of years ago, Office of Water Programs, in coordination with City of Sacramento and several other partners, developed a series of low-impact development features through grant funding from the state of California. And so we have a number of features throughout the campus. It was a successful demonstration project. And as part of some of our asset management training, we've gone out and done surveys of these. And we mentioned, as I mentioned, we used one of those open source apps that you can still download at this point, the CUPS mobile app. And we were able to go out and collect information on them. Now, when I went to the, when we went out and collected information on them, we exported the data, and it's exported as a CSV, a comma-separated, comma-delimited separated file. This is a file format you would save out of Excel. And so you can't directly upload an Excel file within GIS. It's easier to use a more common format for CSV. So if I upload this exported file from the mobile application, then we see here our assets and some attributes that have come out of that app. So these are all different features on in our area. How are we going to get them to actually map onto a location? We use these two fields here. So with features that sort of have a particular point, you'll have a latitude and a longitude that you're typically familiar with, and you can delineate those for particular fields. So we're going to go ahead and insert, declare which fields should be used for spatial information here for point coordinates. And I'm always forgetting which should be latitude and which should be longitude. If you think back to high school or middle school geography, latitudes help you climb up a ladder, but if you can't remember, you can always go to Google and type in a simple question and it'll help you. So I added those layers, and you can see here, a little bit faint, green. They're sort of blending into the background. So I'm going to change the color scheme to be a little bit easier to see. So these are actually the locations of the features that we went out and collected information on from the field. Now the nice thing is you could walk out in your service territory with a pad and paper, use your phone to collect the locational coordinates and write down the features by hand and come back and enter it into an Excel sheet, and you'd be able to also create a map like this fairly quickly. So it's a matter of automation, but there's always an easy way to do things. Now, if we want to sort of zoom in on some features of this, particular attributes, this information button allows you to explore that. So if we click on this, it'll ask us which layer are we interested in understanding more about the features. And so this is the counties layer that we added. We're all within one county, which is why it highlights everything. And then this is the individual LID feature here. And if we do that, it brings up this table here with records about information. Do we see here we have just original cost, replacement cost, some data that we inputted from the field. And so you can manipulate information in Excel, upload it to QGIS and vice versa. And that's kind of the value of geographic information systems, is they allow you to interact with the data in multiple ways, depending upon what you need to do. A few last items I'll mention just as we're looking here. This processing toolbox over here allows you to access a number of the different functions. So here's one of those integrated software programs I mentioned, Saga. And if you click on the drop-down menu, Saga, and you look at, say, terrain analysis for hydrology, you'll be able to develop stream networks, catchment areas, look for upslope areas, topography, a number of different potential functions. One more item I'll mention too. So here's the plugin box. So if you want to actually go and search for a plugin that's not part of QGIS, the package that's distributed, you go to plugins, manage and install plugins, and it will bring up your repository of potential plugins. So you could search a particular name, for instance. So I mentioned that QWater package here. It's already installed in my desktop version, but you could be able to upgrade it or install it here. And then you can access those. They'll appear as menu items underneath. So I'll show you one more complicated spatial layer. Because of the usefulness of GIS layers, many are available online, so that if you're working in a medium-sized municipality, for instance, they may have an openly published or internal GIS record database that you could be able to utilize. So you just, in those cases, you want to be able to download it and get it to a map. So this that I just uploaded is a file for storm drain systems in the one we saw in LA County. But because we're looking at Sacramento, we can't find that. And if I want to zoom to that quickly, you click on the layer and right-click, zoom to layer, and then we see the storm drain system in LA County. So kind of two representations of a very simple GIS, GIS representation of LID features at Sacramento State's campus, and then a much more complex GIS database with thousands of features in the storm system in LA County. And the final item that I'll note is within the gravity mains, the storm system here. If you open the attribute table that I mentioned, it's a drop-down menu. From a right-click, it'll bring up, depending upon how many features are in the file, it can take some amount of time, but it'll bring up an attribute table that'll demonstrate sort of all of the attributes that are within the within that layer. So. So the last item to note, where can I find data on QGIS? If you're already using GIS and you want to enhance your library or you want to get started. So a number of different sources are available, local and state GIS repositories that might have administrative boundaries for cities or counties or infrastructure information. There's the U.S. Census Tiger data set, so perhaps you need to consider aspects of socioeconomic or sociodemographic factors, population or household income from U.S. Census data. So the census block groups and tracks. The National Geodatabase has information that you can pull from the wealth of information that's within the U.S. Census databases. A lot of U.S. federal agencies have significant GIS repositories at this point. So the USGS, Geological Survey, here in Sacramento, we're co-located with them on Sacramento State, but there are USGS offices throughout the country as well as the national, and they have a wealth of water-related information that you might be able to utilize. And then Esri has been building a significant open data hub where you could be able to upload files and download files and use them. That's an excellent source of information these days. And I'll put in a plug for an online discussion forum news site called GIS Lounge, which is a really nice place to find information on latest updates for new software and opportunities related to geographic information systems. So with that, that concludes the presentation today. Hopefully it was a helpful introduction for you. Some links here for the Environmental Finance Center at Sacramento State, where we have some resources for asset management and utility applications. You can feel free to email me directly with any questions, and we'll be happy to get you in touch with your local environmental finance centers or other experts to answer your questions. And then a few links for some to be able to utilize QGIS and access some tutorials for getting started. So I'll turn it back over to Tess, and thanks for your attention.
Awesome, thank you so much. That was a really thorough overview, and we do have quite a few questions, so we'll do our best to get through all of them. But if we don't get a chance to answer your question, what we'll do is reserve them and try to get back to you after the webinar concludes. So the first question, Eric, this may have been really more covered during your demonstration, but it doesn't hurt to talk about these things again. But can QGIS shapefiles be imported into AutoCAD or Civil 3D maps or other programs, essentially?
Great question. I'm sure there are folks on the call or on the webinar today that would be better able to answer that. I actually haven't used AutoCAD in about 10 years. So the short answer is you can always find a workaround conversion for something in my experience, but I don't have direct experience lately bringing shapefiles into AutoCAD.
Okay, great. And then the second question that we have here is, can utilities in Canada use QGIS?
Yes, absolutely. It's downloadable. There's actually the QGIS community is international. And some of the nice examples of really robust applications for QGIS come from Europe and other places. So it's widely available.
Excellent. Okay. So all of our international listeners, I guess that's good news for you. Next, can Esri geodatabase files be uploaded into QGIS?
No, not directly. This is one of the drawbacks between the two programs. There might be some workarounds for let's say folks who are very adept at using it, but what we'll do if we're moving between those file formats is save the individual files within the geodatabase as they shape files, and then you can upload those individually.
Great. The next question is a little different in scale, but if you're a small water utility just getting started using QGIS, what kind of computer or hardware would you recommend using to ensure that all the storage and speed is adequate and capable?
Sure. So right now, the presentation I was running was on a laptop, and it's a 2-year-old Dell computer. So it doesn't have to be anything fancy for sure. When you're working with spatial information within GIS in general, when you start to get to a record, a database with, say, 5,000 records in it, so 5,000 different assets, it'll still be manageable with a desktop computer or a laptop, but a desktop computer that has a bit more processing capability will run things faster, would be the way to say it. So you can process a lot of different types of information on a simple laptop or a simple desktop computer that's nothing fancy. It just takes a little bit longer, that's all. So that's the main trade-off. If you're looking to build a spatial database with thousands and thousands of records eventually, you might want to invest in some good desktop software. If you're starting to use applications where you're building in databases, either through, say, an ArcGIS Esri geodatabase or some of the other open source tools that QGIS integrates in with, some of the additional software that you might need, a more robust desktop will probably be a little bit helpful. But for just getting started, you can use your run-of-the-mill laptop.
Excellent, great. And if you're like some of the municipalities I know, maybe it is time to replace the computer from 2007 anyway. So next question is, does QGIS project on the fly to reconcile mismatched coordinate systems or projections like ArcGIS does?
It does. This has been a feature that's gotten a bit better over the years, actually. Let me see here if I can show. So down here in the bottom corner, it's way at the bottom of the screen, this is the coordinate reference system selection box, and then this is the checkbox for rendering on the fly. So this would be rendering the map, so you can change that. And then within the projections, or within the project drop-down menu here, I believe it's within the properties of the project itself, there's a toggle box that'll allow you to say whether you want it to project on the fly or not. The default within QGIS at this point, fairly similar to ArcGIS, is that you'll be referencing the base map or the layers that have a particular coordinate reference system within QGIS, but it's, in my experience, there's some more bugs in it. It doesn't quite do it as directly. So sometimes you'll have to go into a file and change the coordinate reference system to match if the metadata is incorrect. The one major drawback, though, that I do find within QGIS is that you'll set up a complicated analytical process, and 15 minutes later it'll run, and then you forgot to make the reference systems matched for the two files. So if you want to do spatial analysis in QGIS, you have to just make sure it's sort of it's like a fundamental step that might be covered in a commercial software program, but it's not quite as integrated here. The layers the CRSs have to match for spatial analysis.
Great. And then switching gears a little bit, are there any tutorials or training programs that you know off the top of your head that could be another resource to check?
Yeah, I placed down here, if you can see this, the QGIS tutorials is a nice place to start. A number of different universities, if you search for a particular thing you're trying to do, or a number of different private sector posting boards will provide specific information on what functions to use to do particular tasks. And in that regard, if you're trying to do a particular task and you want to know what function to use, like should I clip the files or intersect them or whatever, the files are similarly linked to the names that are found within ArcGIS, an analytical toolbox. And sometimes it's actually easier to find information because the open source community sort of directs you to the menu items sometimes a little bit more succinctly than the help functions within Esri's software. So generally, yes, there's some good tutorials to start. The QGIS.org site and QGIStutorials.com are two places to start, and then you can just Google particular items you need to find additional resources.
Okay, and it is 3 o'clock, so there were a few questions we didn't get to, but I will follow up with Eric after this and let you all know the answers to those questions as best we can after. I want to point out quickly, I did put a link to our survey in the chat box, so please take some time to fill that out if you can. And for those of you wondering how you can get your hands on the presentation, you can go into the handout section on your GoToWebinar dialog panel and just download it directly today, and we'll also be uploading it to our website. Last thing I want to do before we start to close things up is quickly, we have a final poll. We always ask folks on our webinars if they're interested in technical assistance. A lot of small systems qualify for free technical assistance from the environmental finance centers. And, you know, for example, this is one area where we could possibly help you a little bit more get set up with QGIS or a similar program. So go ahead and just quickly select one. I won't leave this open for very long. It looks like we're good to go. And on that note, Eric, do you have anything you'd like to close things off with?
Thanks for your attention, and I hope everyone is able to stay happy and healthy these days.
Okay, great. All right, thanks everyone. Have a great afternoon.